Do you see my slides?
Yes, we can see.
Okay, perfect. Thanks, everyone. It's very good to virtually see you. So I am Maria. I'm an assistant professor at Duke, and previously I was an associate research scholar and an associate director of the Princeton Edge Lab, and I also teach edge computing here at Duke. So I'm very, very excited to be a part of the institute. So so my lab works on we're here on the fourth floor of Wilkinson, brand new lab, great space. We work on pervasive systems in general, Internet of Things in particular, and recently a lot of our work is on mobile augmented reality. So our core goal is to build mobile augmented reality that is context sensitive, that adapts to the environment and that adapts to the users. And that is at the same time safe and secure. So mobile augmented reality that you would truly trust your life to. And this is where there are lots of synergies with the work of Morley and Miroslav and Neil and several other people who are a part of the Institute. We work on many elements of mobile augmented reality. We work on improved perception, on improved interactions with the user. We showcase new applications. For instance, augmented reality for surgical applications or augmented reality that has some safety properties. So for instance, where holograms that are blocking your view of important objects are automatically moved out of the way of important applications. So in this talk, I'll specifically focus on our work on augmented reality as supported by edge computing, and specifically augmented reality as supported by edge-based intelligence. So overall, the architecture that we are working towards is shown at the high level here on the screen, that we have multiple user devices that are perhaps co-located or perhaps separate from each other. They are supported by the edge servers, and they are connected through the broader cloud infrastructure as well. And we are so in this type of architecture, we can use edge to run additional intelligence on behalf of mobile devices. We can use it to coordinate multiple devices or to even coordinate devices and sensors, for instance. So just taking a step back, what actually is augmented reality? So augmented and virtual reality are mentioned together, but they're actually quite different. And that virtual reality puts a user in a completely virtual world. But augmented reality places virtual content in the view of the user in the actual physical world around the user in real time. So you see some of the examples here. So for instance, to the left of the diagram, this is an example of an IKEA Place app where a couch is placed in context of the living room. And in the middle, it's an app, Google Translate, where pixels in a foreign language are replaced with pixels in the language of your choice. And to the very right of the screen is an example of a New York Times app where they've developed pictures of Olympic athletes in the middle of their impressive feats, and you can actually generate those figures right in the middle of your living room or in the middle of your office. So the core difference between augmented and virtual reality is that augmented reality truly relies on understanding of the physical world around the user. And this is where we really need very high quality perception, many elements of it. AR in general is not new. It's been in development since 1970s, but it has become a commercial technology very recently with the release of several SDKs and headsets from 2016 on. And its reach is expanding every single year. So more and more phones are supporting it. It is easier and easier to use it on cheaper phones. And there are many people who see it as a mobile technology of the future. Apple is hugely behind it, and of course, Facebook, with the recent news about the Meta, Facebook is absolutely all in onto this vision. Mobile AR is already very impressive. So we already are able to merge physical and digital worlds in it with beauty and precision, and some of the applications just blow your mind. But as soon as you start playing with it, you realize that it's still a toy, and that resource consumption is prohibitive. Security and privacy are still major limitations. And this element of perception and situational awareness is very poorly handled in many elements of it. AR makes a lot of mistakes. It has lots of issues with spatial consistency. And as other autonomous systems, it has many issues with its understanding of the world. So this is where we we develop architectures where we are using edge to improve AR in many directions, but specifically I wanted to mention some of our projects that directly relate to edge-based intelligence. So the first one is edge for improving depth perception in augmented reality. Depth perception is crucial for the generation of correct holograms, since otherwise, if you make mistakes in depth, you generate objects that are either too large or too small, as is shown on the screen here. The chair is huge and the echo show is tiny, since we got the depth wrong. So in our recent work, we've built an edge-supported system where we're doing so-called depth data in painting on the edge, and we are transmitting the information back to the mobile device for hologram generation. So this improves the performance, but the core challenge here is, this is perhaps typical of mobile offloading challenges, that we have a very complex DNN that needs to run at very fast at frame rate. So in this case, we are solving both the challenges on the network side to make it run faster, as well as many challenges that are associated with the offloading itself. So compression, encoding, choosing which frames to transmit, and all of that. In our other line of work, we are using edge for combining results from multiple devices for improving semantic awareness. So the intuition here is that if we are able to take pictures of the environment from multiple angles, we can then intelligently combine this information to get to better recognition results. So we use edge for it. We've developed an architecture where we are able to use edge either in asynchronous or synchronous fashion for collaboration. And the challenge here is how to aggregate these dynamic results well. The other line of work that we have is on user context awareness. And this is where we are using user gaze information specifically for headset-based AR to detect what the user is doing and to adjust their experience based on that. So here we are using edge for processing sensitive gaze data. Our core challenge in this case is that gaze data is very, very private and it's difficult to collect. So we do a lot of work on on few-shot learning, as well as on new ways of generating synthetic data for these cases. And we have a very broad line of work that we are starting on incorporating edge, mobile AR, and the Internet of Things at the same time. So our preliminary work and our experiments show that we can use IoT-based sensors and actuators to support mobile AR, to do some of the environmental awareness on behalf of mobile devices. And this requires new techniques for merging data and for processing it together. So I'm out of time and happy to take questions.
Thank you.